So hello everyone. I am Théo Giraudet. I am a PhD student working in an industrial context with the OBO company, the company behind Eclipse Serious and Eclipse Serious Web language workbenches. And I am also working with the University of Rennes, where I am supervised by Benoît Combemal and Arnaud Blouin. So in the context of my PhD, I am working about interactivity and collaboration in the context of heterogeneous modeling. And today I'm really happy to present you my work about the interactivity part through this talk named Augmenting Graphical Modeling Workbenches with Semantic-Aware Interactive Features. So before that, a bit of introduction. So I talk about modeling workbenches. Modeling workbenches are basically a kind of ID for DSMLs to providing some DSMLs to help domain experts to do their modeling task. And for that, they're providing a wide range of services such as editors, formators, validators, auto-completion, etc., etc. And as a DSML and modeling workbench is pretty hard to do from scratch, the community provides some language workbenches to help their creation. In the context of my PhD, we are focusing about graphical modeling workbenches, so modeling workbenches providing graphical DSML. By browsing a bit the academic literature, what we found is that we have several studies that identify a lack of usability of the different modeling workbenches. So basically, these studies are expert interviews, and what the experts say is that these modeling workbenches are pretty hard to handle, so the learning curve is not easy, and the different modeling tasks are very slow to do. So to answer to these different issues, the HCI, SLE, and MDE communities work about some solutions to improve interactivity and usability inside the different modeling workbenches. And part of this work is about what we name the interactive features. So features that a domain expert can trigger to improve the usability of their environment. Because currently, if we are looking at the existing modeling workbenches, we have basically all the CRUD operation, create, read, update, and delete, but we don't really have more complex operation to improve the readability, for instance, or the navigation inside a model. So before talking about the approach we propose, I will present you I'm a bit faster. So here just some example of interactive feature we can find in the literature and on some modeling workbenches. So I think you know already some of them. We can talk about the dynamic filtering, the auto layout, graphical search, physical zooming, semantic zooming, etc. And some of them are generic. So for instance, the physical zooming is basically just zoom in or zoom out a diagram. We can use this feature for a DSL, but reuse the same feature for another DSL. But some of these interactive features are domain-specific. So, for instance, if we take the example of the auto-completion, we cannot reuse the same auto-completion from a language A to a language B. So, as they are domain-specific, we have to specify them for specific DSMLs, specific environment, and this is pretty costly because we have currently to do that from scratch. So this kind of interactive feature, we'll name them semantic-aware interactive features, since they are aware of the abstract syntax and the concrete syntax of a specific DSML. So the question we are asking to ourselves is how can we facilitate the development of such semantic-aware interactive features to have these kind of features more often inside the different modeling workbenches. Before presenting you my approach, I will present you some semantic-aware interactive features we are currently supporting in our approach. So the first one is a semantic zooming. Basically, on the right you have a diagram, and you have a zoom in and zoom out feature, so the graphical zoom. And when you zoom in or zoom out this model, you can decide to hide, show, or change the style of different elements from the model. So for instance here, when I zoom out, I will hide the different attributes, because here the attributes will be too small and are not really relevant at this level of detail. The second one is a dynamic filtering. So this is also another filtering feature, but this one is contextual to a specific element. So here I have a small button named show inheritance tree linked to the class B element. We have here a kind of class diagram model with inheritance relation. And so the dynamic filter, when I will click on this button, I will hide all the elements that are not relative to the inheritance tree of the class B element. So this is specific to a focus element. Here we focus the class B. And another thing interesting to know about the dynamic filtering is this filter can be propagated. So if we, for instance, focus on the class D and we click on the same button, I will have the class B that will be displayed, but also the class A recursively. And the last one is a semantic search. So it's a basic search, but apply over the abstract syntax and not over the concrete syntax. So for instance, here, if I search for the Boolean term, I will have attribute A1 that it will be highlighted. Why? Because attribute A1 is of type Boolean, but just here we decide to not display the type inside the concrete syntax. Okay, so now the approach we propose to answer this issue. So what we propose is a new meta DSL named interactivity DSL to describe semantic-aware interactive features. This meta DSL is aware of the concrete and the abstract syntaxes, and we want to integrate it inside different language workbenches. On the right here, you have a diagram presenting our approach. I don't know if this is readable for you. I can try to zoom in better. Okay. So on the top, I have the language workbench. On the bottom, I have the modeling workbench. If I'm looking at the language workbench, I have my usually meta DSL, so the DSL to describe the abstract syntax, the concrete syntax, and we have a new one to describe the interactivity part. And from them, we can create different meta model that will enable the creation, the produce of the modeling workbench itself. In the modeling workbench part, we have a model editor, and through this model editor, we can edit or manipulate the concrete syntax to edit behind the abstract syntax. And what we had here, we added a new interactivity library, and basically this interactivity library is specific to a language workbench. So a language workbench provider has to develop this interactivity library. And basically the interactivity library will interpret the interactivity meta model to apply the different semantic-aware interactive features. So when the user triggers interaction inside the model editor, for instance, the zoom in or zoom out interaction, the interactivity library will listen to this different interaction, and according to what is described inside the meta model, it will decide to apply or not the different interactive features. So, okay. So here on the here you have an example of interactivity meta model. At the bottom, at the top, we have the import of the abstract syntax and the concrete syntax we want to support in our interactivity DSL. And after that, we have the definition, the configuration of the different semantic-aware interactive feature. So the first one is a search, the second one is a dynamic filter, and the second one is a semantic zoom. So for the search, the semantic search, the idea is to specify where we want to search the string given by the user. So first here we want to search in the class's name, then on the package's name, and at the end everywhere if we don't find any result. So here we use a kind of query/path DSL to point to the different elements where we want to search. For the dynamic filter, here this is a dynamic filter to describe inheritance, to show the inheritance tree. We have to specify on which element we want to focus. So from which element we can trigger this dynamic filter. Here we want to trigger from all the classes of UML class diagram. And here you have the filter we want to trigger. So this filter is defined just here. And here we want to show all the classes and all the superclasses of these classes. And as this is recursive, so we'll also display the superclasses of the superclasses. finally, we have the radius here. So the idea of the radius is to restrict the propagation of the dynamic filter. So if we write here 3, for instance, so we will only have 3 steps of the dynamic filter apply. But if we put range as we have in this example, we delegate the choice of this propagation to the end user, to the domain expert, and you can choose to only display 2 steps of the dynamic filter. At the end, we have the semantic zoom. Here we are specifying the different graphical zoom range we want to, where we want to apply our filter. So between 0 and 75%, we want to hide the different attributes. And here we have the definition of this filter. So we hide the attributes, and we eventually change the style of the class's name to increase the font size. Okay, so that is all for our approach. We implemented this new meta DSL inside the Serious Web language workbench, so a graphical language workbench developed by OBO. Serious Web is open source, and this is a project hosted by the Eclipse Foundation. And Serious Web is on the web, as the name say. So we follow a cloud-native architecture. Here you have the technology stack of Serious Web. So for the client part, we use React and TypeScript. For the server part, we use Spring and Java. And between the client and the server, we use GraphQL. So if you don't know what is GraphQL, this is a bidirectional protocol. So we can exchange data from the server to the client, but also from the client to the server. GraphQL is also kind of model-driven, since you have to describe your the schema of the different data you want to exchange. And thanks to that, you can have validation of the data from the client side and also from the server side. And finally, GraphQL is network protocol agnostic, so you can use it over WebSockets, sockets, HTTP, or other network protocol. On the server side, we also use EMF as a meta-modeling framework and PostgreSQL for the database part. One important thing to know about this architecture, that is most of the computation are performed on the server side. So by that I mean even the computation of the layout of a diagram, for instance, is computed on the server side. And thanks to that, we have a client that is really, really simple. We can easily change this client with other client implementation. But an inconvenience in our work about interactivity is from the client side, we don't have any information about the model. We only have information about the concrete syntax of the model, but in our case, we want to potentially apply filter according to the abstract syntax. So due to this architecture, all our logic part of our interactivity DSL, so the interactivity library with all the logic part, is implemented on the server side. Okay, so I will present you a small demonstration of our approach inside Serious Web. Here we are on the home page of Serious Web. We start with the language designer part. On the right, I will increase a bit the font size. Okay, so on the right we have 3 models. The first one, this is basically the meta models of our kind of UML language. The first one describes the abstract syntax, the last one the concrete syntax, and in the middle we have the one describing the interactivity part. I will just display you here the abstract syntax meta model. And if we are looking at the part describing the interactivity meta model, so yeah, during the slide I show you a textual version of the meta model, but currently we don't provide a proper concrete syntax, so we are using the default tree representation Serious Web provide to describe our interactivity meta model. Donc on the right here we have our 3 interactive features, so the semantic zoom, the dynamic filter, and the semantic search, and we have our 2 filters to hide attributes and superclasses. And when we are looking at, for instance, the semantic zoom, here I have one level of semantic zoom. On the right, I have the detail about this level. I want to enable it between 0 and 65% of physical zoom, graphical zoom, and I want to trigger the hide attributes filter. if I'm going to the hide attributes filter, here I can see I have one modifier. This is the visibility modifier to hide or show elements. On the right, I decide to hide elements. And here I have the path of which element I want to hide. So here we decide to use for the path DSL, we decide to use AQL, that is provided by Serious Web, but basically just a kind of variant of OCL if you already know OCL. So here we want to hide all the attributes of our diagram. And for the dynamic filters, it's the same thing. Here we are specifying what is on which element we can apply this filter, so all the classes. And we have all the detail here, so we want to trigger to show the different superclasses. And finally, the semantic search. So we have here three paths to search in the class's name, in the attribute's name, and everywhere if we don't find any result. Okay, so now let's go to the domain expert part. Here I have a small model based on the DSML I described. And now if I zoom out, my attributes are hidden due to what I described inside my meta model, interactivity meta model. In the same way, if I click on the class D element, here I have a button in my contextual palette named Show Superclasses. And if I click on it, I will have class D, class C, and class B element displayed. Finally, in the diagram palette at the top, I have a new icon to search element. So if I type attribute A1, I will have my attribute A1 that is will be highlighted in red. And if I typed, string, I will have attribute A1 and attribute C1. And if we are going to the details of the attribute A1, like that, we can see on the right we have for type string. And this is the same thing for the attribute C1. Okay, so that is for the demonstration. Now a small conclusion. So we propose a new meta DSL to describe semantic-aware interactive features for graphical DSML. Currently, we are supporting 3 semantic-aware interactive features: the semantic zooming, the dynamic filtering, and the semantic search. Currently, an important thing to note is, so I didn't show you the abstract syntax of our meta DSL, but these 3 semantic-aware interactive features are coded inside the meta model. And finally, we implemented this meta DSL inside the Serious Web language workbench. So for future work, we want to generify our approach. Currently, as I said earlier, we are coded that inside the meta model, but we want to extract what we done from this meta model to have a more generic meta model with the idea to be able to add new semantic-aware interactive feature through a library, for instance, through library. And finally, one other idea we have is to implement our approach in GLSP, or maybe Lion Web, with the idea to be able to support more language workbenches than Serious Web itself. Okay, so that's it for my presentation. I have just one question to the audience. Currently, I presented you semantic-aware interactive features for navigation and readability. But we are searching semantic-aware interactive features for to edit models for the edition part. We are trying to implement auto-completion for diagram currently, but we are thinking there are also other kind of edition semantic-aware interactive features. So if you have some idea of this kind of feature, don't hesitate to share them with me. Thank you.
Thank you, Théo. Any questions? Yeah, to answer your question, what about auto layout? Like focus on a certain element and the rest of the diagram is auto layout of the right?
Yeah, we are thinking about auto layout, but auto layout is really a complicated thing. Currently, we are not contributing the interactive semantic-aware interactive features themselves, since they already exist inside the literature, but with the meta DSL. So if we want to implement the auto layout inside Serious Web, for instance, we have to search about existing libraries that provide auto layout to try to branch our approach to them. But most of them are not free or are not really efficient, if I can say like that.
Have you also considered things like nested layouts specifically for semantic zooming? So like BPMN models, for example, have this concept that you can have a submodel then, which is not in the same model, but might be stored in another model. But then if you might want to have zoom in and then basically open the whole model and show it in between the other model.
Yeah, I totally agree with you. Currently, this idea is not an interactive feature, since this is something that is automatically applied when you are doing semantic zoom, for instance. But yeah, we talked about that. I don't think we will implement that currently, but we have this idea in mind, and maybe we'll try to see what we can do with that. Thank you.
Can a user influence, for example, the settings of the parameters of this feature, like from what zoom level on you will see the semantic?
Currently not, except for the radius of the dynamic filter, where you can specify a range and the end user will choose in this range which value you want. But yeah, this is really something that is interesting, because sometimes what the language designer provides is not enough for the end user. But I think this is something that is really challenging in terms of UI. How can we propose that to the end user and keeping that usable? Because we don't want to add too much boilerplate in the modeling environment. So yeah, we are talking about that too, but this is more UI challenges, and we are not working really on the UI part currently.
What's the power you have with this with this semantic zoom feature? Is it just about filtering out and in some elements depending on the zoom level, or can you even go further and change the way these elements are displayed? For example, having the elements within a container displayed as a list if you zoom out, and if you zoom in, displayed as a sub-diagram somehow?
So currently, we can hide or show elements. You can also change the style of an element, but if we are looking at the implementation I done inside Serious Web, we can only change the style, but keeping the same style. So for instance, if you are representing your node by a rectangle, so you have to keep the rectangle style, but you can change the color or something like that. But currently it's more an issue about my implementation than about our approach. Yeah.
I could actually add one or two.
Okay.
Closing and opening blocks. Right. I have like 15 attributes. And
folding.
Yeah, folding.
Yeah, but we think folding is more. Yeah, you can infer this feature from the AST. From the abstract syntax, I think. So if, even from the concrete syntax, for instance, if you have a rectangle and in this rectangle you have children, so you can infer that you want a fold option for this one. So this is a bit the issue we have with the folding. We don't really see the how can we add more useful features around that can be described by the language designer. But if you have some idea about.
The other thing is, of course, I don't know if this matches your idea of semantic feature, like having an embedded textual editor, right? The classical thing, I want to have a good editor for my constraints in a state machine.
So blended modeling currently,
yeah.
I suppose. So this is not an interactive feature too, but if I talk about our experience at OBO, we tried to do some prototype about blended modeling. So at the beginning with Xtext and Eclipse, the desktop version, where we trying to maybe not having directly the text field inside the graphical editor, but yeah, to be able to use the text with Sirius. I also presented at EclipseCon 2022 our work with Langdev, and we're integrated Langdev inside Sirius Web. And I think we also have other prototypes about that, but I don't remember them currently. But we are working on the papers about Sirius Web, and we are talking about this blended modeling part. So if you are interested, don't hesitate to read it.
Any other questions? Last call, otherwise we have 3 more minutes for coffee, which is also nice. Okay, then.
Thank you very much.